Yeah, I'm going to talk about dependencies and that you need to know about your dependencies. Because as we are working with Java application, if you have questions, please put them in the Java track, and I will try to answer them if we have enough time, because we're already running a little late. We're going to talk about dependencies today, because we think about dependencies a bit lightly. We treat our own code very specific if we look at it and we make it maintainable and scalable. But most of the times, the dependencies are not that much a concern, which is not a good case in my opinion. So first of all, you probably have seen me already on this stream a lot because I'm here for a few hours, but I'm Brian. I am a Java developer and currently a developer advocate for Snyk. I do some work for the community. So I co-run the Virtual Java user group and the Utrecht Java user group. And I am one of the co-leaders of the MyDevSecOps virtual group, which focuses on secure application development and AppSec in general. Well, let's continue because this is the most boring slide ever, right? Dependencies. Why do we need to talk about dependencies? Well, if you think about it, like you treat your code very good, I hope. You have unit tests to test your own code. We have things like, well, say code reviews in place, or things like pair programming. So we make our code as good as possible. But if we look at the binary you put into production, say this is that big yellow ball is that binary that you put into production. If we compare that to the code that you actually wrote, it's probably more or less like this, or maybe even smaller, because we depend a lot if you do Java development, but it also counts for Kotlin development, NPM development, or whatever. We depend a lot on third-party frameworks and libraries. And that's good because they do the heavy lifting for us. So depending on them is for a good cause because we want to focus on business value. However, if we focus a lot on that blue dot and our own code on how good it is, and we forget about the big yellow part, is that fair? Let me give you an example. So we have a Spring Serverless example over here, and this is a code snippet, but the total code snippet was 222 lines of code, right? Kind of okay. It was a demo application, but still. It had 5 direct dependencies. And as we know, dependencies bring in dependencies, bringing in more dependencies, right? And it's Spring. So we don't know actually what we do because we bring a certain Spring boot starter in. In total is about 54 dependencies. But the amount of code you actually put into that binary is massive. Almost 500,000 lines of code. So basically, the ratio is just 1%, is less than 1% is your own code, right? So we do have to take care of these dependencies. And how are you doing this? Well, first we need to take care of how we choose our dependencies, right? I mean, if we do it the right way, let's look at how we pick our dependencies and how we choose the right one for the right job. And that's the first thing already. How can you see that a package that you depend on, because that is a dependency, is the right package for you? Well, first of all, it needs to solve the problem because you're trying to solve a problem with software in general. But does the package that you import solves your problem, or solves your problem only half, or actually does not solve your problem but just helps you a little? So is it actually contributing to the features you want to make? And that seems obvious, but it not always is. Trust me. Then we come to the second one. That is, do I actually need that package? For instance, if I am a Java developer and I'm working and I need to do some string manipulation, and I'm using the string utils from Apache Commons, do I actually need to import the whole Apache Commons Lang 3 library, and I just want to use 2 functions in that library? Is that good enough a reason? Or is it easy enough to do that string manipulation yourself at that point? Think about it. Okay, so you have found a package that does the job for you. Then we need to see if that package is still good, right? And finding it on Stack Overflow with a code example is not a good reason to do so. Trust me. I fell for that trap once or twice. Anyway, we need to check if that dependency, that package, is still healthy. So, for instance, how many contributors are there? Is it actively maintained? Are there newer versions out, or is it actually already end of life? One example: if you want to do circuit breaking in Java REST applications, don't go for Hystrix anymore because that is end of life. Although there are a bunch of examples on the internet. Maybe you need to try another library that is still maintained and not end of life and still actively contributed to. So say we have an example like here. I'm having an example of the Eclipse Collections library. I'm an active contributor to that. So yes, I'm doing some advertisement on this open source library. Anyway, as you can see over here, and I'm looking at the Maven repository of you see that this package is actively maintained. The last version that came out was 10.2.0, and it was released in February 2020. Fair enough. Last one before was in January 2020. So actively, you see that there is a cadence in that release. Every year, there are a couple releases of this package. So that seems legit, right? People are still releasing it. People are still working on it. So the next step, what I normally do, or what you normally should, is look, for instance, at the GitHub repo. And if I look at the GitHub repo, I can get a bunch of stuff out of this. This was a screenshot from yesterday, from that same Eclipse Collections library. And as you can see, it's actively maintained. The last commit was 11 hours ago. Well, yesterday, 11 hours. So a day and 11 hours ago. But you see, there are a bunch of contributors on it. So it's actively maintained. That it has a bunch of stars in the top. You see 1.4K of stars. So people like that library. People are actively using library. People are actively maintaining that library. But what you also can do, you can look at the issues. If a certain issue hits the functionality that you want to implement, because if you try that and you find out in production that something goes wrong, you need to get it out again and need to fix it, right? And why is this important? Because you're depending on it, and you build your software on top of this. So if something breaks and it's not maintained, then you are in trouble and you need to fix it yourself, need to rewrite, make patches, get it out. And if it's actively maintained, you can ask the contributors to help you with this. So, and then is the third question is, do I need all of this? And again, I use this Eclipse collection library because it's quite a large package. If you look at the size of the jar, it's 9.8 megabytes, which is not that much for a Java enterprise application. But, and that's a big but, if you do, for instance, Android development, is this something you want? And compare it to what you actually use in the library. If I'm just using an implementation of immutable list or a tuple, is that actually worth it to put that 9.8 megabyte jar into my application? You need to think about it if it's okay for that. And some people say it is, but I would say if it's just a single collection or a single implementation, maybe you can implement it yourself or find another library that's also actively maintained that is lighter, because it might have performance impacts, right? Okay, so we have our initial stack of dependencies. Then we come to that point, like when to update dependencies. Well, some people say I will never update dependencies. If it works, if it doesn't break my unit tests, it's fine. I beg the difference. First of all, if you are working on an active application, you need to upgrade, right? You need to upgrade, for instance, from Java 8 to Java 11, and that can break things. I mean, first of all, you have to look at your dependencies. If you look at your dependencies have indirect dependencies. Cool. If you want to update, check if it's still regularly released. If it was regularly released in the beginning, doesn't mean it's still there, because if I used Hystrix 5 years ago, it was perfectly fine. Not anymore, right? So you need to look at all these things that you did at the beginning, plus the dependency health. And we will get into the dependency health. Because if you don't do that, things will break. As I said, I was in a project a few years ago, and in that project, we needed to convert from an old Java 6 version to Java 8 at that point. It was like 8 years ago, and Java 8 was at that point the newest one. Java 6 was already end of life, but because people postponed to also update the other dependencies, by updating from Java 6 to Java 8, we had issues with the Hibernate layer, with Spring because it was ancient, and we need to cut open the whole big monolithic application and make sure that all these dependencies were up to date again. So you should take care of them, because if you don't take the pain now, if the pain is little, then you need to take the pain later, and the pain will be getting bigger and larger, right? So take care of that. So how can your package manager help with that? Well, let's, for instance, Maven. If we have Maven, you can use the Maven versions plugin. And I will just show you that because it's easier to show you. Say I have this application, and you see these are my dependencies, right? And I want to see if there are newer versions of these dependencies. Well, let's go to the terminal and let's say Maven version display dependency updates. And by just running this, Maven will look for me, and if there are newer versions of that dependencies, and you see for all 4 dependencies, there are newer versions available. So you don't have to look it up manually. You can use your package manager to do so. So that also means that you can automate it. You can automate this while you are building your new release in your CI pipeline and give a warning or give a report on that. It doesn't mean you need to upgrade everything. That's up to you if it's needed, but at least you know there are newer versions, right? So I can see for all my versions over here, I can update to a newer version. And if I do that constantly, you will see that the pain is easy because these are just minor versions. And minor versions, minor updates are not that big of a problem most of the time. Most of the time, it will not break API. And if it breaks API, well, you might still want to do it because if you do it later, the pain will only get worse. So getting back to my slide deck, this was for Maven, and you can basically do the same for Gradle. For Gradle, if you use dependency updates, you can look, and if you can see if if there are newer versions of that. Okay, next one. Do you know if there's an issue with the dependencies? For instance, are there security problems? Let me check for that. So say I have an application over here. This is just a Spring application, and I'm using an ancient or an old Spring Boot implementation, and I'm using the CRUD repository, and I'm using Spring Data REST. It is a grocery list, and I already started up for you. And if you look at over here, it's start up. If I ask for item /1, it will give me my first item on my grocery list. If I look for item /2, it will give me the second item on my grocery list, etc., etc., etc. And Spring Data and Spring Data REST help me with creating a CRUD repository and making that CRUD repository into a REST repository, so I do not have to do anything. And if you test it from a functional perspective, it looks great. It works fine, right? Cool. But let's get into something else. Say I don't know and I don't test my dependency, and I'm doing this. Like what? I'm doing a curl command, a curl patch command. And in this curl patch command, I know this version of Spring Data REST is vulnerable. And in this vulnerability, if I do a curl patch command, I can utilize a Spring expression language. And I do this by inserting this JSON body. With the Spring expression language, I can alter objects, or I can make new instances of new objects, right? And what I do over here is I make an instance of the runtime, and I give it the env command. And the endpoint I call it on is the endpoint for my first item on my grocery list. So nothing special. But by doing this, you see I can do an arbitrary code injection or an arbitrary code execution. I can basically call any Linux command that is available for me. So if I don't know that this dependency is vulnerable and I keep it in, you are in trouble. You might be in trouble. And how can you solve that? Well, I did it already for you over here, and I will enlarge it a bit so you can see what I did. I did a sneak test, and this is free software, so you can use it right now. Just download it and do it. And it helps me on my command line to see that, okay, I need to update from 155 build snapshots to 210 and to get rid of a bunch of these problems. The same for another package to update. So this helps you out, and you can automate it again. And this you can do on your local machine, but also like this is another repository, but I connected it to a scanning tool, the Snyk scanning tool for my repository. And you see it scanned 6 hours ago. So on a daily basis, I scan my repository to see if there are problems. And you see there are a bunch of problems over here. And of course, that's on purpose. So use these tools to help to see if a dependency you have is vulnerable or has a security issue. So you have a reason to get it out. And what I want to say is, if you are going to the latest and greatest in general, the possibility that something goes wrong will get smaller, but not impossible. So you need to know what the health of your dependency is, and use that as one of the things to make sure that you're good up to speed, right? So, okay. Our dependency, we know what our dependencies can do, and we know if the head of the dependencies are cool. But then we end up with when to remove a dependency. I mean, I know there are a bunch of users out there that use Maven, and probably the most of the people over here use Maven and have seen a POM file, right? This is a part of a POM file. And this is a part of an old POM file or an old project I worked on, like I think about 5 years ago or something, or even more. And the point with that POM file was it had a lot of dependencies, and nobody knew anymore if the dependency was used, why we use it, and actually, if I snooped around on it and I looked into it, and it had actually 3 implementations of a XML parser in it. Why? Do you need that second one? Isn't there already one that helps you? And maybe we should convert that into one, right? So, but there were also a bunch of dependencies that were not used anymore. So why not get these out? Because you see that even if a dependency is in through things like reflection and stuff, this code might be used or might be utilizable or whatever. I mean, it doesn't mean if it's not directly used, it cannot be indirectly used. So if you do not use it directly, you might try to cut it down and make your POM file or your Gradle file as small as possible so you can actually see what's going on. So how to do that? Well, for instance, we can use the Maven dependency and analyze plugin. And I will show that again because I have this Maven dependency thing I showed you earlier. And say I am doing, I have these 4 dependencies, right? So I'm doing Maven dependency analyze, and it will analyze the dependencies that I'm using or not. And I will just enlarge my screen a bit so you can actually see the stuff. And what you see over here is that it gives back my unused but declared dependencies that it had found. And one is a test dependency and one is a provided dependency. Well, I'm not interested in my test dependencies. I'm not interested in a provided dependency because, well, I need it. Well, if you want to use Lombok, but in this case, I might use it. So it's not something you actually do, but it's more, no, you can provide, you can see it more or less as a runtime dependency, right? So what we can do is, for instance, do -d ignore non-compile. By doing this, it will only show me the compile dependencies that I pull into my application, and these are not used. So I can now see that I depend on a commons lang library, and I'm actually not calling it. So this is an indication. It's not perfect, trust me, because the point is, if you use Spring Boot starters, for instance, a Spring Boot starter has the issue that a Spring Boot starter is actually an empty jar with only a POM file in it. And the analyze plugin will look if there is a reference to that jar or not. So they will come up with these Spring Boot starters like they are unused and declared. Yes, fair enough. But it gives you an indication if there are unused dependencies, and you can use this tool to cut down your POM into the smallest one you actually need. And getting back to Gradle, there are a bunch of plugins to do so. And well, I looked into the Nebula plugin, which is a plugin, if I'm not mistaken, created by the folks from Netflix. It's a Gradle lint plugin, and you can use the unused dependency rule, like specified over here, to do the same thing in Gradle. So both in Maven and Gradle, there are tools that can help you. It's not a perfect tool, like it will actually get everything out, but it can help you maintain your dependencies and cut things out that are not needed anymore. So I will go for a small recap because we only have 30 minutes in this talk, and I only have basically 1 minute left before Q&A starts. So first of all, think about how to deal with your dependencies. Make sure that you and your team have a strategy how to work with dependencies. And if you want to create a strategy, make sure that you think like, why am I implementing this dependency? Not just do it, but use that as part of your code reviews. For instance, why are you including this dependency? Is this needed? Just like you look at your code in a very specific way, look at the things you include as well. You need to check your dependency health. Like, is it maintained, but also, is it still secure? And if it's secure now, it can be like insecure tomorrow because it takes time to find vulnerabilities, and a vulnerability can pop up like in any time. So make sure that you scan for these things. Make sure that the dependency health is checked over time. So if it's good now, it might be that like in a year or so, this project is out of date. And if you see that, for instance, the amount of commits go down, or that people are not actively maintaining it anymore, that is a cue for you to get that dependency out and get a new version in, or get a new project in that is well maintained. I would say update often to newer version. The better, the more the better, because increments are most of the time are small. And if you take the pain now, you will have less pain than if you postpone it to the end of whatever, when you actually need it. Because if you need to implement a new application or a new framework and it's not compatible with a bunch of your dependencies, then you might be in trouble. And then you need to do a whole lot of rework to just make it compile and make it run. Remove unused dependencies because you basically don't know what they're doing, and it's just sanitization. You also do not leave that code in, right? We do something like that code analysis to make sure that our code is compact and clean and maintainable, because readability and maintainability is one of the most important things if you work in a team. And last but not least, try to use these tools as I just gave you. And these are just a few of these tools, but you can use these tools to automate as much as possible. Don't do this manually, but make this part of your build process. If you do that, like with every Maven build, that you get a report and a warning like, okay, there are a bunch of things wrong, or in your CI pipeline, you will get actively pinged if there are issues with newer versions, if there are issues with security, for instance, so you have a reason to update. This is my recap, and I will shut off my screen and see if there are any questions. 1 second, please. Normally there's a host doing this for me, but I need to do it on myself, on my own now. So let me get over here. Let me get into the Java track channel. There are no questions there. And let me see if there are questions in the Slido. Should we write it ourselves for the small things? It's always dependable on. Somebody asked, should we write things ourselves for the smaller things? That depends on your situation. In some cases, yes. If you do things like if it's easy, for instance, if I want to use the implementation of a tuple, and I want to include the whole Eclipse collections library in it, I mean, I can write it in 3 lines of code. Well, maybe 5. So yeah, that would. But it's always a trade-off. So it depends how much do you use. If I would say use as little dependencies as possible, but that's not always the case in enterprise Java. But take it into account. That's what I wanted to say. But for small things, if you can write it yourself and you can look at it yourself and you do like reviews on it, why not? Right? Except, there's always an exception. Don't do implementations of encryption, for instance. So pick your battles. Next question is, what if we use Artifactory on Nexus for jars and it's not up to date? Yes, I get that. That's an issue. But I think that's there for a reason. If it's not up to date, then you should consult the architect or the one that the person that is in charge over there. Like, why don't we update these things? For instance, scan your dependencies if there are vulnerabilities in there. If not, then you're good to go. But probably there will be some problems in there. I'm getting pinged. I don't see it anymore, but I think my time is up for now. It's I've got 1 minute left, so I see on the clock. So if you have any more questions, please put them in the Slack channel and I will answer them for you over there. I want to thank you. I want to thank Snyk, and I want to thank all the talks organizations for doing this, for raising money, and wow, thank you all for being here and for donating money.